Good morning, everybody. We're going to do an experiment on the transition elements. One of the characteristics of transition metal compounds have beautiful colors. So we'll illustrate that using chromium. And one of the properties of the transition elements, they have multiple oxidation states. In the case of chromium, they have oxidation states from +6 all the way down to -2. And three of the most important ones are +6, +3, and +2. We'll do all those today. We're going to start off with dichromate. Potassium dichromate contains chromium and the +6 oxidation state. It's the dichromate ion that makes it orange. Potassium ion's colorless. So that's the amount we're going to use. And we're going to reduce it to chromium 3 first. And we're going to use zinc as a reducing agent. It's a pretty good reducing agent. And now then we're going to reduce the chromium 3 to chromium 2, and you'll see what those look like. Get this thing going. So what I'll do is I'll put the zinc in here. I think so. Like a stupid joke, I think so. And then we'll put in the dichromate. And then we'll add some water to it. Let's just mix it up a little bit. Ready? I'm adding 8 milliliters of water. And the dichromate is soluble in the water. Let me mix it up a little bit. And then we'll add hydrochloric acid, and that'll start reacting with the zinc. And that'll activate the surface of the zinc to reduce the chromium 6 to chromium 3. See if there's any evidence of reaction here. See any evidence of reaction? Yep, it's reacting with the zinc. And it's making hydrogen gas. And I'm going to put this on there and direct the hydrogen gas off to the side there. Can you see it's changing color? By the way, whenever that's chromium 3 is green, and when you have an equal mixture of green and orange, it's called yuck. They're complementary colors. It's yucky looking now, right? But you see it's gradually turning green. Can you see it? Yeah, it is, isn't it? No doubt about that. Once we lose all the orange color and you see the green, then we're going to do another experiment, because the second reduction from the chromium 3 to chromium 2 takes longer. And I'll wait till it happens to show you how beautiful that chromium 2 is. It's really pretty. It's starting to turn a little blue now. Yeah. You see it's getting bluer now. When it gets finally to chromium 2, it'll be kind of a sky blue color. So while that's going, we're going to do another experiment. What I have in here is iron 2 ammonium sulfate. And it's nearly colorless. The compound itself has a kind of a light green color. You can see the color of it. But in dilute solution, it's hardly colored. And we're going to oxidize the iron 2 to iron 3. I think dichromate will do that. It's a good oxidizing agent. And when it oxidizes it from iron 2 to iron 3, the dichromate with the +6 oxidation state for the chromium is actually reduced to chromium 3. And we now know the chromium 3 is green, right? So let's see if there's any evidence of that happening. Is there any evidence that it turned green? It sure did. So we reduced it from chromium 6 to chromium 3, and that's chromium 3. You can see that's bluer than that now. It's getting blue. So let's let it go a little bit longer, and then we'll do another experiment with the chromium 2, which is the sky blue color. It's pretty blue now, isn't it? This is essentially completely reduced now. See, it's nice and blue. And this is chromium 3, which is green under these conditions. And then remember, this is the dichromate. +6, +3, +2 oxidation state. So what I'm going to do now is I'm going to take that blue solution, pour it into this beaker here. Now it is blue, isn't it? It was blue, isn't it? It's pretty blue, isn't it? Now I'm going to pour this nice blue solution in here so you can see it better. Okay. Now what I'm going to do is I'm going to shake this up here. See if you see anything happening. Is it changing? It is, isn't it? Isn't that getting green? It is getting green. Isn't that getting green? I think it is, isn't it? It's getting green, isn't it? See, and it turns out that chromium-2 is a good reducing agent. And the only way we could keep it was to keep it under the hydrogen, which is a reducing atmosphere. And now this is exposed to the oxygen in the air and it's turning green again. Isn't that turning green? It sure is, isn't it? It's about this color again. There's that green. It is getting green. So chromium-2 is a good reducing agent. Chromium-6, a good oxidizing agent. Chromium-3 is in between the two. So the chromium-2 was oxidized to chromium-3, and the other one, it was reduced from chromium-6 to chromium-3. And that's a good place to quit, don't you think?